Hi friends, welcome back. Today we are going to solve AtCoder Beginner Context 210 problem. The name of the problem is Colorful Candies. Before we start looking into the problem details, some examples related to this problem and the Java solution, I just want to mention that my channel is dedicated to help people in their Java J2 interviews and coding interviews. On my channel, you will find a lot of helpful videos that can help you in your Java and coding interview preparation. There are over 300 different videos that help you like in solving, like it shows more than 300 different varieties of solved problems that are coding interview questions previously asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other financial tech companies. And those are selective problems in the sense that they cover a wide range of very important coding questions varieties such as breadth first search, depth first search, graph problems, binary search tree related coding questions, coding questions related to linked list strings, optimization problems using priority queues, dynamic programming related coding questions, as well as a lot of logical problems that can be solved with different data structures such as set, map, queues, stacks. So you will get vast varieties of different coding questions here that can help your preparation. So please subscribe to the channel now. So let's first go through the problem statement, then we'll go through some examples, and then we'll formulate our algorithm to solve this problem. So there are n candies arranged in a row from left to right. Each of these candies has one color, that is one of the 10 colors, right? There are 10 colors. It can have any color, like 1 to 10 are the colors, right? So they have given us that. From this row, Takahashi can choose k consecutive candies and get them. That is, he can choose an integer I such that I will be between 1 and n minus k plus 1, and get the ith, I plus 1th and I plus 2th until I plus k minus 1th candy from the left. Takahashi likes to eat colorful candies, so the more variety of colors his candies have, the happier he will be. Print maximum possible number of distinct colors in candies he gets. So that is what the problem is, and they have given us some examples here. So I created one example where we can like I can explain you the problem better, and we can also formulate the solution here. So the n is total number of candies. So n is equal to, as you can see, these are 8 candies that is given to us. The color can be between 1 and n, right? 1 and 8. So that is different colors of the candies. So for example, if you choose this candy, its color is 1. If you choose this candies, its color is 2. Now the problem is basically says that Takahashi has to choose k candies, such as the k are consecutive candies, right? For example, consecutive 5 candies he can choose, any consecutive 5 candies. For example, he can choose these 5 candies, right? These are the 5 candies, but they should be consecutive, correct? Like this basically. And what we have to choose, we have to do here is we have to find out the maximum different colors of the candies that he can choose in the 5 consecutive candies. The color should be maximum colors basically, right? So what do we mean by colors? So if we choose these 5 candies, then the colors will be 1 2 3 here, right? 1 2 3. So there are only 3 colors, different colors, right? So we have to choose maximum different colors which is possible in the given candies. So that is what the problem statement says. So um, basically from the problem statement itself, you can you can understand that it's kind of a sliding window problem, right? Where we have a window of 5, right? And that window we are going to slide, right? And then we will also have to keep track of the types of candies we have seen, correct? So let's go ahead and let me copy this array here first, so I can show you what the sliding window means. So 1 to 1, then here this is 2, this is 3, and 4 to 1, right? So this is given to us, this array. So what I mean by sliding window is we have to create one window. The window size is 5, for example, right? So this is the logic we are understanding how we can solve this problem. So this is, for example, a window, right, of size 5. So this is size 5, right? 1 2 3 4 5. So what we will do is we will create this kind of window, and we will keep track here of what is the different types of candies, right? Different types we have seen, and we have to also keep track of the basically the maximum that we have seen, right? The maximum we have seen. So for example, if we choose this window, right, of size 5, then we are seeing three types of colors here, right? 1 2 3, correct? So we will keep moving this window, and at here we will keep incrementing the max that we have seen, right? So max is 3 now. So we will now move this window by 1 unit, right? So once we move this window by 1 unit, it will look like this, correct? So now again we will keep track of how many colors we have, right? 1 2 3 4. So 4 types of color we are seeing here. So which means that we are going to increment the max, because our max is now 4, because here we are seeing 4 colors. So we will keep moving this window. Now again we will keep moving this window by 1 unit. So once we move this by 1 unit, it will look like this, right? This is now the window moved by 1 unit. Now how many colors we are seeing here? 1 2 3 4, right? Again we are seeing 1 2 3 4. So 4 types of color we are seeing, but we will not update our maximum, because maximum is already 4, right? We will update the maximum only when we are seeing a value which is more than maximum value, right? Otherwise we will not update. So here we already have seen 4 values, so we will not update. We will again move our window to 1 unit. So now this is our window now, right, after we move by 1 unit. So now as you can see here also we have 1 2 3 4. So there are 4 different colors we are seeing here, correct? 4 different colors. So we will not update the max will still remain 4, because 4 is not greater than 4, right? So at the end, so we have reached the end now, right? This is the end. So whatever is the maximum we will return as our answer. So 4 is the answer basically for this, right? So maximum, uh, like if k is equal to 5, the maximum types of candies he can find is 4 basically, correct? So like that basically, correct? So one other thing is, for example, if you just assume for a moment, if you assume that instead of this one, if this is 5, let's say if this is 5, right? In this case, the last window, this is our last window, right? This is the last window where we have 5 elements. Now as you can see, still it will be 4 only, right? 2, like 2 3 4 5. So still it is four different types only, correct? So 4 different types only. So we will also always have to keep track of what is the number of different types we are seeing basically for that window, right? So how we can solve this problem basically using algorithm or using Java, right? So one good data structure we can use to solve this problem is hash map, right? We will use hash map to solve this problem. So let's go ahead and let's take a look of how we will be solving using hash map. I will remove all these windows so you understood the logic of the sliding window, how we are going to use it, right? So let us take a look now how the hash map will help us, right? So we will take the window size 5, and we will always keep the frequency of all the elements into the map, correct? So let us say this is our map, right? So this is our map. So map will have key value pair, right? So 1 2 3. So these are the numbers, right? And we will keep track, value will be the frequency of the number, right? So 1 appears 2 times, so we will keep track of the frequency here. 2 appears 2 times here, right? And 3 appears 1 time, correct? So 3 appear 1 time. So after we went through all these numbers, we will just update all these frequencies, and we will have to check whenever we are entering any value into the map, we will keep one counter, right? Let's say one counter will be there. um, so you can just say one count. So or let me just go ahead and let me take the same name that I used here. So we will just say current is the name I use, so I will just take the same name, so it will not be confusing to you. So we will just use one current variable, right? And current variable, whenever we are inserting a new value here, right, like 1 we inserted, then 2 we inserted, 3 we inserted, right? So in that case we will update the, we will increment the current, right? So the current will become 3 here because we inserted 3 values, right? 1 2 3 in this window. So current will become 3, and our maximum types of colors that we have seen in this window we will become 3 basically, right? Maximum will become 3, right? 1 2 3 colors we have seen. So now what happens is, now we will keep moving this window until we reach the end, right? So now we will keep moving the window, so now our window will move like this, right? So this is the new window now because it moved by 1 unit. So now 4 is inside our window, so we have to add 4 here, right? 4 1, so 4 and its frequency is 1 we added. So when we are adding, we increment the current count by 1, so current count became 4. But at the same time, one actually, one went off the window, right? This one, this is out of the window of the current window, right? So we have to update its count, like frequency count, right? So 1 was 2, so 1 will become 1, right? The frequency of 1 is 1 now. As you can see in this blue color window, only 1 is there, so we'll update the frequency. After we are done with this process, again if you see the count, like all these elements into the hash map, there are 4 elements, right? 1 2 3 4. So in that case, our maximum we have to update to the size of this map. So size of the map is 4, so we will update the max to 4, correct? So after that, again we will keep moving our window, so our window will move again by 1 unit. So now the window will look like this, right? So now window will move by 1 unit, so this is our new window now, right? So 1 2 3 4 2, so this is the new window. And when we are taking a new window, as you can see, now these two went out of this window, right, of the new window. So 2 is off, so we have to reduce frequency of 2 by 1, so we reduce the frequency by 1. But here we are in adding one more 2, right? So again we have to increment also by 1, right? So again it become 2, right? So we decrease by 1 and increase by 1, so it basically stays the same, right? So again it is 2. And you can easily see that these are the two 2's here, right? This is 1 2 and this is second 2 in this red window. So this is the frequency we updated, and after that we will again keep checking the size of the map. So size of the map still remains 4, right? So current will remain 4, basically current will remain 4, right? So it did not change, so current is still 4. So we don't have to update the maximum, right? Because maximum is already 4. So we will keep going, and we will keep moving the window. So now our window will move to the next position. So this is the red window, so we will have to take this part now as our new window, right? So this is our new window. So 2 3 4 2 1. So now we actually one went off the window, right? So this one is out of the window, so we have to reduce the frequency. So once frequency is 1, so we reduced it to 0. When frequency is 0, it means that we don't have that, we'll just take out that element, right, from the map, because its frequency is 0. So there is no point of keeping 1 here, correct? But at the same time, you will see that before we can take it off, we will also be checking what new element got added into the window. So 1 got added into the window, right? So which means that we have to again put the 1 frequency of 1 as 1, right? So we will not remove it, because it's kind of you removed it and you again put it back, basically, right? So 1 will be there in the map, its frequency will be 1, correct? So total, again if you calculate number of elements into the map, there are 4 elements into the map, right? So current is 4, right? And current is 4 and maximum is 4 at this point. So it means that he can get maximum 4 different types of candies, basically, right? So that is the maximum number of candies, so we have to return 4 as our answer. right? So this is the approach we are going to take to solve the AtCoder problem, colorful candies. um, so if you have, like, this is another example that they have given us here. The window size is 3, so I'll just quickly show you this example and then we will go to the actual solution, right? So let me just take this array here. So 1 2 1, then 2 3 3 1, right? 2 3 3 1. So this is another example. This is the one that they have given us right here. So if you look at this, the example is from here, this first example we are looking. So window size is 3 here, right? So again we will have a map, right? We will have a map, and this is our map, let's say, and this is our max, right? Max is 0 in the beginning, correct? And current is also 0 in the beginning. Current is also 0 in the beginning, right? So we will take the window like this. So this is our first window with window size is 3, right? So it has frequency, we will update here. 1 will with frequency is 2, and 2 has frequency as 1, right? 2's frequency will be 1. So total size of the map is 2, right? So current will be 2 here. Basically current will become 2. So whenever we are adding any new element, we will update the current, we will add the current, right? Like this, when we add first 1 and this 2, then we will add to current, like current will become 2. But when we are adding this one, we will not add anything to current because 1 is already been added basically, right, into the map. So we will not update in that case the current value. So our max will become 2 because we have the size 2, right? So 2 we already found here. So we will keep moving with the window. So now our new window will be this one, right? This is our new window. So when we are here, our 1 is off the window, right? This is went off the window. So we will decrease the frequency of 1. So the frequency of 1 will become 1, and we added one more 2 here. So frequency of 2 will be increased to 2, right? But still the size of the map is still 2, right? So still 2. So max will be still 2. We will not update it, right? So we will keep moving the window now. So the window is moved like this now. So this is the new window now, right? So now we have this. So 2 went off the window. So 2 frequency we will reduce. So 2 frequency will become 1, and 3 we added. So whenever we are adding new element, we will have to add it to current also, right? So current will become 3, and 3 will have frequency 1. So our max we will be updating from 2 to 3 now, because we are seeing 3 different elements in the current window, as you can see, right? 1 2 and 3, right? So like this basically. Now we will go to again the next window. So next window will look like this, right? So at this point the 1 went off the window. Now 1 will be off the window. So 1 frequency will become 0. So once frequency will become 0, we will remove this one, right? So we will remove this one basically, correct? And 3 we added. So 3's frequency will be added. So 3 frequency will become 2. Now there are only 2 elements. So current will be decreased by 1. So now current will become 2, right? Because we are decreasing from 3. So it was 3, but now it became 2 because one of the element went off and its frequency became 0. So we have to reduce the current in that case. So again current is 2. We will not update the max. Max is already more than current, and we will keep moving the window. So now our window will be this, right? This is the window 3 3 1, and at that time 2 is out. 2 went off the window. So we will reduce the frequency of 2. So from 1 to 0. So whenever it becomes 0, we will delete this element. So we are deleting this element, right? Because its frequency became 0. We added one new element 1. So its frequency we are adding it as 1. So there are again 2 elements here, right? So current value will be 2. Why it is 2? Because we added 1 to current value, but we also subtracted 1 because the 2 frequency became 0, right? So we subtracted 1, we added 1, so it is basically staying the same, right? So again only 2 elements are there into this window. So our at the end the maximum is 3, so this is our answer basically, right? So if you look at the answer here, so answer is 3 here, right? Sample output. So let's go ahead and take a look at the colorful candy solution. So I already will give you the link here, and I'll also put this link of the AtCoder problem at the description. So let's go through the Java solution quickly. So this input is given to us in the problem. So this is the problem that we had discussed first, right? 8, 5, and these are candies of different types. So there are 8 candies given to us. So we will first define a map, right? It's a hash map of integer comma integer. So it will keep track of the like every type of candy and its frequency basically, right? So this one actually is a type, and so this is basically candy type comma frequency map, right? So that's what we are doing here. So once we also we will take left and right pointer basically, right here. So left and right pointer is basically we are simulating this window, correct? So we are simulating the window. So let me remove this, so I will show you what I mean actually. So the left and right pointer we will take here in the beginning. So right pointer will move here, right? And whenever the difference between right and left become 3, then that is our current window, right? So this is our current window, correct? When right is here, left is here, so the difference between right and left becomes 3. So this is the current window. So we are simulating the window moving thing, like the window moving scenario, by using left and right pointers, right? So here right is 0 and left is also 0 here, right? So in this while loop, current is 0 in the beginning, and result is the one that we are capturing the maximum, right? Result we will use that. And here in this while loop, what we are doing is we are actually moving the right pointer, right? So in the beginning, right pointer and left pointer are both here, right? This is right and this is left. So right pointer will keep moving basically. It goes here, then it goes here. So whenever right pointer moves here, the actual window size become 3, right? So that's what we are simulating, and at the same time we will keep track of, we will keep adding these values like 1 to 1 into the map, right? And we will keep updating the current value also. So as you can see, we are getting color, then we are checking into the map the value of the color. If it is 0 means it is, if it is a new color, right? If it is a new value, right? If it's a new color that we are seeing first time, right? So in that case we have to add it into the color, like into the current we will increment current, and here we are putting into the map and we are incrementing the right? So it will go through the until the end of this current window basically, right? So like this, as I've shown you here. After that we will update our the with the current we will update our result, right? Result is the maximum basically. We use this max variable here, right? This max, so max is basically result here, right? After that we will take the left color out of the color window, right? And we will take check its frequency. This is the frequency of the left color. If its frequency is becoming 1, then like we will just do current minus minus, right? Means it is going out of the window and its frequency is 0 basically, because it went off the window, right? Then in that case we have to subtract it from the current value by 1, correct? So as I explained you in the example, and we will have to add this new value into the map, right? New value into the map we will add, the new frequency we will add. So to keep track of the actual the maximum value, we are actually going to use the current. This current we will use for, not the map size, right? The current we are using basically to keep track of the what is the different colors we are seeing in the window basically, correct? So we are using the current variable for that, as you can see here. So whenever we get the current value more than the current result value, then we will update result, so that result will always show up the maximum value, and at the end we will just print out the result here. The result is the maximum candy types that Takahashi can see by using the k is equal to 5 value, right, which is the maximum window size. So let's take a let's execute this code snippet and make sure it gives us it's giving us 4 as the answer. So 4 is the correct answer, right, as we saw here in this example. We can take another example. We can take this example that they gave us. In this case the answer should be 3. As you can see, I'll just highlight, this is the window, right, 1 2 3 is the window where we are seeing maximum 3 types, right. So let me just take that example and make sure that example also works here. So we have to just update this input here, right, with the new input. So this is the same example now. So as you can see, we are getting 3, which is the correct answer for this example that we have seen, right. We can take this last example also. So let me just update this quickly. So there are 5 ones here, right. So 5 ones, 1 2 3 4 5. So here as you can see, even if the size of the window is 5, then sorry, it's all 4s, right, all 4s basically, not ones, all 4s. So you can see that there is no variety here, so he will always get same type of candy basically. So one type of candy only he will get, right. So we are expecting 1 as the answer. So let's execute this snippet. So we are getting correct answer. So this is the way you can solve the colorful candies problem on AtCoder. If you are new to my channel, there is a playlist called as there are different playlists. If you are preparing for coding interviews, the name of the playlist is, one is Code Forces, other is Leetcode and Leetcode Solutions, other is Code Chef, and I'll create the new playlist for AtCoder also, and I'll put this there. So this playlist has over 300 different varieties of solved coding interview questions which are previously asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many others. And they constitute lots of different varieties. For example, in the current problem, we have seen that this can be solved with the help of sliding window approach easily, right? So similarly, there are other varieties also covered that includes BFS, DFS, matrix problems, graph coding questions related to binary search trees, binary search related problems, as well as the coding questions related to linked list, strings, optimization problems, and varieties of other logical questions that can be solved using different data structures like set, map, queues, stacks. So you can go through those videos when you are preparing for your interviews, will definitely be helpful to you. If you like this video, if you like the content, and if you like the way it's been created with whiteboarding session examples and Java code, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of this channel is to help people in their coding problem solving and in their Java interviews. They can also watch these videos and understand how to approach and solve different varieties of coding problems using Java, and how to use different data structures, Java libraries, and APIs to solve different varieties of coding problems. So if you like this content, please share this content with your friends and colleagues who might be preparing for coding interviews or Java interviews. They can also watch and get benefited by seeing these videos. If you find this content helpful and if it helped you in understanding this problem, please give it a like, and I'm gonna give you the Github Solution link of the actual Java code. You can go and check it out from there, and practice it with different unit test cases for your better understanding. And thanks for watching this video.